Hello and welcome to today's capacity webinar entitled The New NetFlow, a 20-year-old secret for better network management. I'm Natalie. 20 years since Cisco first introduced NetFlow as a scalable way to track network activity without collecting raw packets. To this day, network operators who use NetFlow and other types of flow data for network management still report the benefits, which include a lightweight monitoring footprint, faster troubleshooting, more effective planning, and automated security. However, when any technology survives for 2 decades, it raises the question, is NetFlow outdated? Are there other sources and technologies that are newer, faster, and more detailed for achieving network visibility? This session will answer what is new with NetFlow, why NetFlow is more useful than before, what are the new native fields in network that extend visibility MPLS, and how you can achieve enrichment by adding data that's not within flow records. I'm delighted to introduce our key speaker today, Jim Meehan, Head of Product Marketing at Kentik. Jim is a longtime network enthusiast, founded one of Chicago's first dial-up ISPs in the early 1990s. His career includes stints in network operations and vendor pre-sales engineering, including more than 10 years at Arbor Networks. Currently, he leads the product marketing team at Kentik. So just a quick housekeeping point before we get underway. Today's session will be available on demand, and in true capacity style, there will be chance for a short Q&A. So please do submit your questions at any point using the Ask a Question box below the screen. And with that, I'm going to hand over to Jim to start his presentation. Over to you, Jim.
Hi there, good morning, and thanks for the great introduction, and thanks for attending and listening to our presentation about what's new with NetFlow. So by way of agenda, we'll talk about a few different things. First, I want to spend a little bit of time talking about the history and background of NetFlow, so we're all on the same page. And then we'll discuss all of the new aspects of NetFlow that make for some interesting use cases. And then a quick bit about Kentik, and we'll have some time for Q&A at the end. So I just first will ask the question, what is NetFlow? And NetFlow essentially is telemetry about network traffic. So we have all of this data passing by on the network, and we want to find out some statistics, some summary information about what that traffic is like and what it consists of. NetFlow is produced by network elements, so routers, switches, virtual devices, SD-WAN devices, and now public cloud has NetFlow-like data that we can get. And NetFlow is essentially like call detail records for IP traffic. So if you think of call detail records as the items that you might see on your mobile phone bill that tell you where the call was made to or where it was received from, how long it lasted, how much you got billed for it. NetFlow is like that for IP traffic. So it tells us the source and destination of the conversation, the services involved, ports, protocols, interfaces, how many bytes, how many packets. So we don't need to look at the raw packet contents. We're just looking at the summary about the layer 3 and layer 4 attributes of the traffic. NetFlow was originally invented by Cisco in 1996, and it was a byproduct of flow-based forwarding. So they simplified having to look up a routing decision for every packet in the routing table, and instead created a flow table so that they could use that information to forward packets rather than having to look up the information in the routing table each time. And then they realized that if you exported the entries in that flow table, you'd have a very handy way to get telemetry about the traffic. We use NetFlow as kind of a overarching term for all types of flow data, but there are actually multiple different formats, including SFlow, which is more like packet header sampling. Now also IPFix, which is an evolution of NetFlow that allows for a flexible set of fields or attributes to be included in the records. And now VPC or NSG flow logs, which are what's exported from public cloud environments like AWS, GCP, and Microsoft Azure. So we might ask also, why NetFlow? And the big advantage is the ability to gather detail about network activity without having to collect or decode all of the raw packet data. So in that way, it's a very lightweight monitoring technology, and it leverages the hardware that you already have deployed in your network. So you don't have to add new sensors, hardware, packet brokers, other things that you might get or have to do to look at that raw packet data. And it gives us information like the total volume of traffic, and also allows us to segment the traffic by source or destination, application, a lot of other attributes that we'll be talking about a little bit later in the presentation here. And it's great for both historical and real-time monitoring. So we can save the NetFlow data to look back in time that happened previously, or trend how traffic is changing over time. We can also look at traffic in real time. So that allows us to troubleshoot problems that are active in the moment, or do detection by comparing the flow data that we're receiving in the moment with baselines or historical activity that was seen in the past, so we can do change detection. The other great thing about NetFlow is that it's pervasive. So if you have routers, if you have a router or a firewall or a switch, or in the public cloud, we can get this telemetry to help us understand what's happening at that part of the network, and to shine light on problems that may be occurring, so that we can troubleshoot much more quickly by having this real-time visibility. So let's dig into the mechanics of how NetFlow works a little bit. The devices that are handling traffic, the network elements like routers, are typically sampling packets out of the live traffic stream and creating a flow table. And so for each unique combination of attributes, and that is fixed or configurable depending on the version of NetFlow that we have, we create an entry in the flow table or the NetFlow cache. And so if it's the first time we've seen that unique combination of attributes like source and destination, ports, protocols, an entry is created. If we see a packet where we have a matching entry already, then we update the existing entry to increment a counter for the number of bytes and packets associated with that flow. Then either after a timeout or when that conversation has ended, that flow record gets exported to a NetFlow collector as a UDP packet. And typically there's multiple flow records packed into a single. So the way that NetFlow looks on the network is actually a stream of UDP packets sent from the router to a collector sitting elsewhere on the network. And the format of those records varies depending on the NetFlow version. V5 is an older NetFlow version that has a fixed set of fields. SFlow, rather than building a flow table like this, it's just exporting the header of individual sampled packets. And then IPFix and Cloudflow logs are more modern versions of NetFlow that provide some flexibility in what attributes are contained in the flow record. So they can actually have a record format that's defined by the user in the router configuration, and they can include application level detail, some other things that we'll talk about in just a moment. So now that we have a little bit of background, let's talk about what's new in NetFlow. And we're going to cover three primary topic areas. One is extended and vendor-specific flow fields. So these are things that are contained natively in the NetFlow record exported by the device. The second area is the possibility of enhancing the native NetFlow data with external data sets by correlating flow with those data sets. And the third area is new ways to collect and process flow data that weren't really available or possible in the past. So extended flow fields allow us to have data in a NetFlow record that goes beyond the TCP 5 tuple or this fixed set of fields that we typically think of being contained in NetFlow records. So those historical fields are things like source and destination IP address, the IP protocol, source and destination ports, ingress and egress interfaces. The newer flow formats like IPFix or NetFlow v9 have fields available that go beyond what was traditionally collected. And so those can be layer 2 attributes like VLAN IDs, MAC addresses. They can be application layer details like app ID, which you might get from a firewall or a load balancer or some routing devices. And then possibly vendor-specific fields. So different types of devices from specific vendors might have attributes that are included in the flow record that are specific to that type of device. So for example, Palo Alto network firewalls can export the user ID associated with the flow as part of the flow record, which can be very useful for tying network activity back to individual users on the network. We also have extended flow fields in the flows that we get from public cloud environments. So VPC flow logs from Azure and NSG flow logs, VPC flow logs from AWS and GCP and NSG flow logs from Azure contain information about the elements in the public cloud environment that the traffic was to and from. So things like the VM name, VPC name, project name, all of that is added into the flow record so that we can get more context about what actually generated traffic or received it. Firewall devices and some routing devices can give us information about the forwarding status of a flow. So if the flow was dropped because of a policy or an ACL, the flow record will tell us that the flow was dropped, that it was blocked, and it'll tell us the reason. It'll give us the ACL ID, or maybe it was dropped because there was no route. And then many routing devices can also give us information about encapsulation or overlay network information. So things like MPLS tag IDs and VRF identifiers for traffic that was forwarded by a virtual routing table. So we'll talk some more about some of these things coming up. The firewall use case is pretty interesting. So of course, firewalls produce logs about what actions they took on traffic, but logs don't give us all of the information that we might want for really troubleshooting what's happening with the traffic passing through the device. And so there's a couple of different situations where you might want to be able to take a closer look and actually visualize or dig into what the firewall is doing. And one situation is where you want to verify that the policies you have in place on the firewall are having the intended effect. And so that means that they're not blocking things that they shouldn't be, and that they're also not allowing things through that should be blocked. The overblocking troubleshooting scenario is pretty common. So one situation that we actually encountered in our own corporate office was a situation where a firewall was overblocking traffic to and from Google Hangouts. And by accepting flow data from that firewall and visualizing what the firewall was actually doing with the traffic, filtering on traffic that was denied, we could see that the traffic was being blocked by an ingress ACL, and specifically which ingress ACL was responsible for dropping that traffic. By looking at the service name or the destination of that traffic. So we could very quickly find which policy was responsible for blocking the Google Hangouts traffic that was causing calls to be unreliable or drop in the middle of the call. So there's a lot of situations where firewalls are blocking things they shouldn't be, and being able to pinpoint that quickly allows operations teams to be more efficient and solve problems for users that are being affected by that overblocking very quickly. So we talked a little bit about cloud flows, and this is a great advancement for public cloud environments, a relatively new offering across all three major public cloud providers. VPC flow logs are essentially flow-like data that can be exported from the public cloud environment. And the export mechanisms are a little different across the three major cloud providers. AWS will stick the flow logs into files in an S3 bucket where they can be retrieved from. Google allows you to send subtopic that a consumer can then subscribe to and get those flows out of. And Azure has a couple of different delivery mechanisms, but a common way is to have a listener process that accepts the flow logs and then archives them or does something else with them. The great thing here is that we can now regain the visibility that we're used to having in on-premise data centers, using traditional NetFlow. We can get that same visibility now in the public cloud, and that's been a gap for since the introduction of public cloud environments, where there just wasn't much information about the traffic flowing between VMs or services in the public cloud. The other great thing about VPC flow logs and NSG flow logs is that they contain fields that allow us to identify the specific resources in the public cloud that traffic is to and from. So actually contained within those flow records are the names of VMs and the project ID that they're associated with and the VPC ID. Google even includes latency information in their VPC flow logs, so we can get performance information out of public cloud without any additional instrumentation. It's all built into the behind-the-scenes networking. So this is a great way to understand the relationships between resources or services in the public cloud, and especially great for troubleshooting hybrid type of applications, where part of the application is running in an on-premise data center and part of the application is running in the public cloud. Now, with NetFlow from the data center and VPC flow logs from the public cloud, you can see both sides of that application. It makes troubleshooting much, much easier. A great use case for VPC flow logs is to understand what drives networking costs or networking charges in public cloud environments. So the bills that you get from AWS or Google have line items that say for region-to-region traffic and an amount and a cost. and there's really no detail or breakdown of what was responsible for generating the traffic that those charges were associated with. And so if the charge is bigger than you expected, you have no visibility to understand why that happened. So VPC flow logs are great for shedding light on that situation. We can see by summarizing or aggregating those VPC flow logs exactly which VMs, sources, destinations, teams, applications, etc., were responsible for the traffic that generated those charges. So you can see the diagram here is showing relative traffic volumes, and you can get the exact traffic volumes too, broken down by source and destination, project, and region to region or zone to zone associations. And so this allows us to allocate those costs to different users or teams, or however you want to break it down, so that we can bill back those charges internally or associate them with the correct budgets, or maybe we see some resources that are being used inefficiently, and we can go back to those teams and say, hey, is it possible to refactor your application to reduce the network load? It looks like this is possibly inefficient or unnecessary. So there's no way to answer those questions or engage in those activities without the visibility that we get from VPC flow logs from public cloud. So looking into MPLS traffic is and traffic associated with VRFs or virtual routing and forward instances is another area where built-in fields in flow records can give us some additional visibility. So in the past, oftentimes we had no visibility into MPLS traffic that was crossing the network, especially in the middle of the network. Let's say I'm a carrier and I provide multi-point MPLS services to a number of different customers. At the edge, I can see pretty easily which customer the traffic is associated with, which VPN the traffic is associated with. But in the middle of the network, I don't have any visibility. In many cases, the routers in the past haven't supported exporting flow for MPLS traffic. But even if they do support that, I don't have a good way to associate things like MPLS label IDs with individual customers. So now, with newer routers, newer OS versions, I can get MPLS data and VRF identifiers associated with flows exported from routers in the network. So that allows me to look at links in the middle of the network. Let's say I have a capacity issue with one of those links. I can see now which customer VPN that traffic is associated with and make a more informed decision about how I'm going to address that capacity issue. So, one option is just to blindly upgrade the capacity of that link, but if I get information about which customers are causing traffic growth on that link, I can make other decisions like rerouting that traffic within the network. Makes troubleshooting much easier as well if customers are complaining about performance problems or slow speeds. Being able to see which customer the traffic is associated with in the middle of the network provides a much easier troubleshooting workflow. Likewise, maybe I have both VPN traffic as well as native IP traffic on a link. I can now see much more easily how much traffic is associated with each of those VRFs. So I might have a global VRF that carries the native IP traffic, and then some other VRFs that carry VPN traffic. Being able to get a breakdown of how much traffic in each, which sources or destinations that traffic is associated with. All of those things are now questions that I can answer using MPLS and VRF ID fields that are exportable in IPFix and V9 NetFlow formats. So this is an example of how I might break out traffic on a link where there are multiple VRFs involved. And I can see, per source location, I have some data center traffic, I have some branch office traffic. Which of those are the major traffic generators through this VRF? Which routers did they flow through? Where did that traffic exit on the other side of the network? And finally, which destination location did that traffic go to? So for traffic engineering, getting a big picture understanding of what the traffic sources and destinations are on the network, being able to associate those routing instances or MPLS IDs with the traffic gives me a much better view. So let's move on to flow enrichment. And this is the idea that we have a great set of information natively in the flow records, but we can make it even better by associating that flow data with a number of external data sets based on common keys that we see in both data sets. So if I have, for example, a BGP table that says this destination is associated with this path, and then I see that destination IP appear in the flow record, we can tag the flow record with the BGP path that was active at the time the flow was received. And so then I can get per flow path information and filter or aggregate over that to understand much more deeply how that traffic traverses the network. The modern way to do this is to, rather than try to summarize or aggregate this data as it's received, think about this as a join on ingest type of situation where, as the flow is received, we will add on these additional attributes as if they were native fields in the flow record, and then store the flow record with all of those additional fields, kind of as like a single row in a database. And then that allows us to, at query time, filter or segment the traffic by any of those attributes. It really makes the data much more human readable, and we'll talk about some of the ways that we can enable that in the next few slides. And it speeds up the workflows a lot. So if I see an IP address in the data, I don't have to go to some other data source to figure out what that IP's function is on the network. Potentially that's built right into the data that I'm storing as part of the enriched or enhanced flow record. So just to visualize what we're talking about by correlating and joining data sets as we receive the data, I've got 4 different potential data sources shown here. One is the flow records at the top. So just to simplify, we'll think about a flow from a source 1.1.1.1 to a destination 7.7.7.7 and some number of bytes associated with that conversation. Then the second data source is an authentication log, maybe from DHCP or a Radius server. And this gives me associations between client IPs and a username. So now I know which user is associated with that flow. And then I can use 2 other data sources. One is DNS logs. So before this client made that connection to 7.7.7.7, I saw it do a DNS lookup for a specific host name. So I can assume that this connection is associated with this, this DNS lookup that was done ahead of time. And then using a database that maps host names to providers and data types, I can tag that flow record additionally with the traffic type and the provider, and store all of this together as a single data record. So the native flow data only had these last three fields, but by adding on this additional context, I understand a lot better what that conversation was about. So that allows us to do a whole bunch of interesting things. One is in a service provider environment, I can actually identify traffic types and who that traffic belonged to. So the first graph here is showing, and I apologize for the small text, but it's showing a time series graph of traffic by content type, right? So how much was audio, how much was video, how much was gaming, how much was business applications, those sorts of things. Then if I filter, let's say, just on video traffic, I could additionally break it down by how much is Netflix, how much is YouTube, how much is Hulu, how much is Amazon Prime Video. So this is data that service providers are extremely interested in. Number one, for traffic management, so they want to make sure that they are receiving that traffic via the lowest cost mechanism, right? If possible, they want to put caches on net, or if there's not a cache available, they want to make sure that they're receiving that traffic over dedicated peering links that are a low cost rather than IP transit, which is a high cost. The second reason that providers or carriers are interested in this information is from a product perspective. So they are keenly interested in which third-party services or OTT services are on the rise. How much do subscribers use each of those services? A really interesting upcoming use case is the launch of Disney's new streaming service. And providers want to know how fast are my subscribers adopting that service? Do I need to make plans to handle that additional bandwidth that that new service is going to generate? How is the rise of Disney streaming affecting Netflix traffic? Maybe people are switching to watch one versus the other. And then based on all of that information, I could potentially build pricing packages. Subscribers are using those services or using the network to make it to make the services that I provide to them more profitable for me. Another interesting use case is to understand end-to-end traffic flows. So by marrying up the flow data with BGP data and kind of adjacent network data, we can build maps like this one that show for the traffic that I received in Chicago, who did that come from and via which type of connectivity? Did it come via transit? Did it come via a free peering connection? And where did that traffic go beyond Chicago? Where did it exit my network on the other side? Some of it exited in San Francisco to a customer. Some of it exited in New York to an adjacent network that I peer with for free. Some of it exited in Chicago via a transit provider that I have to pay for. So for carriers, this is a great way to understand how much individual customers cost from a network load perspective. If I have a customer where most of the traffic I receive from them is delivered out of the same POP that I received it at. And especially if I deliver it mostly to my other customers, that's the best case scenario because I don't have to take that traffic across my backbone, and I'm actually getting paid twice for it, once to receive the traffic from customer A and once again to deliver it to customer B. Versus another customer, maybe I receive their traffic at a POP and most of it I have to deliver internationally by carrying it across my backbone and carrying it across expensive undersea cables. So by being able to differentiate how different customers are utilizing the network, I can come up with differentiated pricing that improves margin rather than using just a kind of blended cost across all customers to decide how I'm going to price my service. So that allows me to gain a pricing advantage or a leg up versus my competitors who might not have this level of detail or visibility into how traffic is crossing their network or how what load individual customers are placing. Another interesting use case for correlation or flow enrichment is geolocation data. So there's a number of different providers who will have very extensive databases of the geolocation of IP addresses. So as I receive flows, I can tag all the flows using that geolocation database with the country, region, city, et cetera, where that traffic originated from. And so these visualizations we're looking at here are related to a DDoS attack. And in the pie chart, I can see, let's assume that this is some kind of botnet attack, right, where the attacker has an army of compromised machines that are generating the traffic that is part of the DDoS attack. And so I can see exactly how many unique sources are associated with each country that traffic is originating from. In this case, 4,400 plus IPs in Russia, some more in Brazil, some in the US, some in the Ukraine, so on and so forth. I can also see different sources is entering my network via which adjacent providers at which POPs, who is the target. So this information allows me to make very quick decisions about is this an attack or not? And if I am let's say I'm a cable operator, right, and this is my customer's IP, if I see a customer in the US receiving all this traffic from Russia, Ukraine, Brazil, that looks relatively suspicious, especially since it's so many sources. And so that allows me to make a quick decision about how I'm going to act on this. And then I can also get informed about how my network is being affected. How much traffic is coming in via these different providers versus how much capacity do I have with those providers? Am I congested? That affects also what action I'm going to take. So the last part here is related to flow collection and processing. And this is maybe the biggest advance in what's possible with flow data. So there's been a disconnect since the origin of NetFlow about the promise of having all of this rich detail about the traffic crossing the network, streamed live from all of the devices in the network, versus what was possible in practice with the compute and storage and software architecture that was available in the 90s and even through most of the 2000s. So in the past, the way that we typically dealt with flow data was using single server or kind of monolithic software architecture where we only have a limited amount of disk and CPU that we can cram into a single server. And that kind of forced software that dealt with flow data to pick and choose which data was going to be saved or viewable later. And the way that was done was with filtering and aggregation of that flow data at collection time. So if we knew ahead of time which sources or destinations or interfaces or breakdowns were going to be useful later, we could predefine which pieces of that data to keep and which summaries to build so that we could view them quickly at the time that we needed them. The limitation there is that I can only answer questions that I knew in advance I was going to want to answer later. And so that's the only data that was retained because we didn't have the storage available to save all of the data. And so the result was I have kind of this spotty picture of what's happening on the network, and I can't really answer all of the questions that I need to in the moment when I'm trying to troubleshoot something or when my boss asks me a question about, hey, how does the traffic look for this customer at our POP in London, for example. So what we have available now is modern distributed computing architecture where I don't have to rely on the resources available just within a single physical box. I can use technology like Hadoop or Spark or any number of other open source big data backends to distribute my flow collection over horizontally scalable computing architecture. I can save all of that raw data and then filter and aggregate it at query time. So I no longer am restricted just to questions that I thought of ahead of time. I can answer any question that I have in the data, all the way down to looking at traffic history for a single IP address in a very large service provider network. And if I provide the appropriate amount of resource in terms of disk and network and CPU, that query can be fast. I can answer those type of questions in seconds. So this gives us a huge amount of flexibility, a lot more power to resolve network problems or make planning decisions, understand capacity growth, all of the things that we might want to do with NetFlow data, all of the things that were kind of promised by NetFlow data are now in fact possible because we have this modern architecture. And so two things that are key aspects of that are filtering and output selection. Filtering, I can now get very specific about the set of data that I want to include in my query or get information about. So we can filter on any of those fields from the flow data or the enriched data that we've added on to the flow records. And using these modern software architectures, I can build up very complex filter sets to see exactly what I want. And then I can also get much more specific about how I'm going to aggregate and visualize that data. I can include just the output fields that are meaningful for the question at hand. And I can iterate through this because using these new software architectures, it's fast. So maybe the first thing that I filter on and group by gets me a little close to my answer, but I still need to go deeper. So if the sequence of queries is very fast, I can add additional filters or change what the output looks like, get closer to the answer until I finally arrived at the filter and the output selection that shows me exactly what I need to see. So that brings me to the last section about Kentik. And Kentik is a NetFlow platform, network analytics platform that's built explicitly to provide all of the things that we've been talking about here. We've been around since 2014. We have a huge number of customers across both service provider and enterprise, and you can see some of those here. And our mission in life is really to help network owners and operators make every network that they use, network teams more efficient at all of the day-to-day tasks, so they can focus more of their time on growth and building new capabilities for the business. Kentik is primarily a software as a service platform, so we collect flow data and a number of other data sets from customer infrastructure via SSL proxy or direct interconnection. We mix that with the enriched data sets, some of which we talked about, but there are many others that we did not talk about. And we use that data to provide both interactive query and sort of real-time insight, but also detection, comparing current data against historical data to pull out insights that might require action, either because of a problem or a planning or trending workflow. And then using those insights, we can automate some of these workflows. So either automating the steps in an interactive workflow, or directly resolving problems on the network by interaction with orchestration or chat ops or other types of third-party platforms that may be in use in your environment. About 90% of our customers use our public software as a service platform, but we do offer an on-premise installation as well. And we have a lot of great customers who are very vocal about Kentik, that we really make an impact on the efficiency of operating their networks, and the impact on customer experience for the users or customers who utilize that infrastructure. And so they are able to keep their network more reliable, more performant, and again, keep teams focused on growth and new capabilities rather than firefighting. So that brings me to the question and answer section. And before we get into that, I'll just say thank you very much for taking the time to learn about what's new in NetFlow.
Thank you so much, Jim. That was a really insightful presentation, and I'm pretty sure our audience have a lot of questions to ask, so we're going to go straight into the Q&A. So the first question I have for you is, what kind of network devices can I get NetFlow from?
Yeah, that's a good question. Modern routing and switching devices have NetFlow or another variant like SFlow built into the software and even in the hardware in most cases. So NetFlow is a hardware accelerated function of the device, and it doesn't place additional load on the CPU or the processors. So those devices include things like Juniper MX series is a common platform for customers to send flow from, Juniper EX switches, Cisco ASRs, virtual ASR 1K devices, send S-flow data, and then many other types of devices like firewalls, load balancers can also send flow data. So it's pretty pervasive at this point, and that's great because it gives you that built-in capability to generate this visibility data from every corner of your network.
Great. Another one we have is, are there open source options for NetFlow collection and reporting?
There are some open source options, and I'll describe a couple of different scenarios for open source. So, the full function NetFlow collectors that are open source are primarily still single. They don't offer distributed flow collection or processing. But there are things like PM ACCT, NFSend, NFDump. These are real common tools that people use to get started with flow data. And then for people who do have bigger networks and they need that distributed capability to achieve the scale that's necessary for their networks, many folks have used generic open source big data platforms like Elasticsearch or Druid or ClickHouse or even Hadoop in some cases to receive flow data and other data sets and do correlations. The issue there is that there's a lot of stuff that's not provided out of the box with open source big data platforms. They don't understand NetFlow data as anything other than some data, right? And so a lot of the use cases that you want to do with NetFlow data require some understanding of the correlations between the data sets. You probably want a UI to visualize some of that data. So even if you want to use the platform, there is a lot of work, a lot of development work required around the edges. And some organizations will have the resource in-house to build that stuff, and some will not. They'd rather use a ready-built solution like Kentik.
Great. So another one we have is, what are the security risks with NetFlow, and how do you mitigate those?
Yeah, that's a great question. So I think NetFlow data in general is somewhat less sensitive than other types of data that you might be storing. In that it's just information about conversations and not packet contents. But still, you wouldn't want to expose information about relationships between hosts and services in your network. So there is some importance about securing that data. From the perspective of Kentik receiving NetFlow data, we provide a lot of options to secure both how that data is transported and how it's stored. From a transport perspective, we provide a proxy agent that customers can run on hosts or VMs in their infrastructure and send the flow data to the proxy service, which then encrypts it and sends it out to Kentik over SSL. We also have customers who directly interconnect with us over private network links, like a cross connect in an Equinix facility, so that the flow data is only traversing single tenant infrastructure on its way to us. In terms of storing NetFlow data, it's encrypted at rest on the Kentik side, and we provide. We've gone to great lengths to silo that data per customer, so that all the way down to the disk storage level requires customer-specific credentials to access the data. If there are folks that have deeper questions about how either of those work, I'd be happy to answer offline.
Perfect. And one last one. So how important is NetFlow in the future of network automation? Does it compare to...
Well, I will try my best to answer that question. So, in terms of automation, I think there's been a lot written and a lot of products and software that address the control part of automation and the configuration management part of automation. So how am I going to program network devices at scale? How am I going to make configuration changes at scale? So that's kind of day zero automation. But in terms of actually doing full kind of closed loop automation where I'm observing the network, detecting problems or things that need to be mitigated, and then on the basis of those detections, making changes to the network to correct the problem, I think NetFlow is an essential part there. Especially as NetFlow gets more robust and contains more data than just layer 3 and layer 4 information. I really need some mechanism to observe what's happening on the network at scale if I hope to detect and automate the resolution. And using packet data is really not a scalable or feasible mechanism to do observation anymore. Number one, because the data volume really increases costs by a huge amount if I'm going to try and look at all of that data across a huge environment. Using NetFlow data, I've already got the hardware in the network. It's my routers and switches. And the other problem with packet data is that it's very hard to get in public cloud environments and potentially costly as well. So I can't install a physical packet collector device in the public cloud. So flow data from public clouds, it provides the mechanism to do the same type of full closed loop automation in those environments that I'm starting to look at in on-premise data centers.
Perfect. Well, thanks so much for the questions, everyone, and again for the invaluable information about NetFlows, Jim. You certainly opened my eyes to a number of opportunities with this technology. That is the kind of all the time we have for today, unfortunately, but thank you to our audience for joining us. Today's session will be made available on demand. For those of you whose questions we didn't have time to cover today, I'm sure Jim will be happy to answer those directly. Don't forget, for news, events, webinars, white papers, and more, you can go to capacitymedia.com. And from all of us at Capacity Media, many thanks for joining us.